Let's start with the absolute basics. An expression with an exponent has three key parts. First, we have the base. This is the main number, the one being multiplied. In the expression a to the n, the base is a. Next, we have the exponent. This is the small superscript number. It tells us how many times to multiply the base by itself. That's the n. And finally, the entire expression, a to the n, is called the power. It represents the whole thing, the base raised to an exponent. So when we see 5 to the third power, we can read it as 5 raised to the third power, or simply 5 to the third. Now that we know the parts, let's look at three fundamental types of exponents. First, positive integers. This is the most common type. An exponent like 3 in 5 cubed simply means you multiply the base by itself that many times. So 5 cubed is 5 times 5 times 5, which equals 125. Next, the zero exponent. This is a simple but powerful rule. Any non-zero number raised to the power of 0 is always equal to 1. So 7 to the power of 0 is 1. Negative 100 to the power of 0 is also 1. It's a great shortcut to remember. And finally, negative integers. When you see a negative exponent, just think reciprocal, which means you flip it. To solve a to the negative n, you move the expression to the denominator of a fraction and make the exponent positive. It becomes 1 over a to the n. For example, 3 to the negative 2 becomes 1 over 3 squared, which simplifies to 1/9. A negative exponent doesn't make the number negative, it makes it a fraction. Okay, now for the fun part. Once you understand the basics, you can use a few simple laws to solve more complex problems quickly. These are like the grammar rules for exponents. First, the product of powers. When you multiply two powers that have the same base, you just keep the base and add the exponents. So 3 squared times 3 to the 5th becomes 3 to the 7th. Next, the quotient of powers. This is the opposite. When you divide two powers with the same base, you keep the base and subtract the exponents. So 3 to the 5th divided by 3 squared becomes 3 to the 3rd. Third is the power of a power. This happens when you have an exponent raised to another exponent, like 3 squared to the 5th. In this case, you keep the base and multiply the exponents. So 2 times 5 gives us 3 to the 10th. Fourth is the power of a product. If you have different numbers multiplied inside parentheses, all raised to a power, you apply that power to each number inside. So 3 times 4 squared becomes 3 squared times 4 squared. Fifth, the power of a quotient, which works the same way for fractions. When a fraction is raised to a power, you apply that power to both the numerator and the denominator. So 3 divided by 4 squared becomes 3 squared divided by 4 squared. Sixth, we have a special case for the negative exponent on a quotient. If you need to raise a fraction to a negative power, you simply invert the fraction and make the exponent positive. For example, 3 over 4 to the negative 2 is the same as 4 over 3 squared. And seventh, a very useful application of the negative exponent rule for simplifying fractions. Any term with a negative exponent can be moved from one side of the fraction bar to the other by just changing the sign of its exponent. For instance, in the expression 3 to the negative 2 over 4 to the negative 5, the 3 negative 2 from the numerator moves to the denominator to become 3 squared, and the 4 negative 5 from the denominator moves to the numerator to become 4 to the 5th. This simplifies the whole expression to 4 to the 5th over 3 squared.